Hi, folks. Typically, a site developed with Wix and Velo would be a store or a blog or maybe a personal site, portfolio, stuff like that. But today, we're going to talk about something a bit different, and that is an auto-scalable web service with Velo and AWS. So my name is Jeb, and I'm a guild master and architect at Wix.com, and I've been with Wix for almost 4 years. Although I've been developing software since I was 14, and I really love that. Apart from my main job at Wix, I also run a couple of open source projects and write blog posts occasionally. In fact, this talk will also be available as an article, so make sure you follow me on Twitter if you don't want to miss it. All the code samples and stuff like that will be there. But at this moment, you're the first ones to hear my story, and I'm really excited about it. In addition to being an extremely smart and humble software developer, I also have a few hobbies, like video games, PC, not consoles, this is an important fact, and kite surfing. You see the beach behind me, it's real. But the one hobby that really takes a special place in my life is music. I'm sure any musician will relate to this. I've been playing guitar since I was a kid, and music is one of those things where you're never good enough, but at the same time, you're satisfied even from seemingly insignificant things like placing your fingers in the correct positions. So the story I'm about to tell you combines my two huge passions, music and software. And surprise, surprise, it's also about Wix. The story began around 4 years ago, at the same time I joined Wix. And apparently moving to Wix wasn't a big enough change for me. So I decided that I have to learn a new musical instrument. The choice was between bass guitar, piano, and drums. And eventually I went for drums because, well, bass guitar is still guitar and piano is boring and hitting stuff is fun, right? Well, the decision was made. I bought myself a nice electronic drum set for beginners, took a few lessons, picked up a few fights with my downstairs neighbors, and officially became a drummer. The first song I learned was Lonely Day by System of a Down, and it was quite fun. It's a well-known song, so it had both a drumless version to play along with, drum sheet music, and a bunch of live recordings and drum covers that I could learn from. As the time passed, I started to learn less common songs, and it wasn't as easy as Lonely Day. The covers were bad or absent, the sheet music was wrong or missing, and eventually I found myself wandering around with headphones over my head and listening to the song I wanted to learn, trying to figure out the small details of the drums among other instruments. And the boy, was it hard. That's when I stumbled upon Splitter, the source separation library from Deezer. It's based on TensorFlow, which is a machine learning library by Google, and trained with MuseDB. For those of you who are less familiar with machine learning, the way it works is that MuseDB is a data set that has a bunch of original tracks along with their respective pre-recorded separated sources like guitar, drums, bass, vocals, etc. And then the machine learning model is fed with this data in order to learn the best way to separate the original track into separate stems. And once it's trained, it can separate tracks that weren't in the original data set. Pretty easy. So I decided to give it a try, and I was lucky to be a developer because this is what the instructions look like. I was also lucky enough to be a PC gamer because it works much, much faster on an NVIDIA GPU than on a plain CPU. And I had one of those in my PC. Long story short, I did manage to get it working, and the results were amazing. But the process was far from perfect. Every time I wanted to learn a new song, I had to download an MP3, run a script that uses Splitter CLI to process that file, copy the resulting drum part to my phone or cloud, and only then I was able to connect my phone to my electronic drum set and start learning the drum part. Now, as you could probably imagine, I'm the kind of person who loves sharing. I share the technology I develop by maintaining it as an open source project. I share my knowledge by writing blog posts about different challenges I face on my job. And I share my grievances with my in-game teammates over chat, and they really like that. So this time, I decided to share this amazing library with the rest of the world by providing its capabilities as a web service. Wouldn't it be nice if you had a site where you can enter into your personal user area, upload the file, and have its sources separated without having a dev-specific knowledge or a powerful PC? Wouldn't it be nice if you could listen to all your previously processed files in a single place? I bet it would. And since at that moment, I had already been at Wix for a long enough time to know the internals of the group I worked at, I wanted to explore and understand the capabilities of the larger product that Wix is developing. So I decided to learn the product by developing this web service on top of the Wix platform. Now, before we dive into the details of architecture, design, and implementation, let's try to understand what capabilities, both functional and non-functional, are required from a system in order to build such a service. So let's just break it down. First thing you need is to upload a file. So we need a web client with UI that allows us to do so, a CDN, content distribution network, that serves this web client, and some kind of server-side file system where you'll save the file once uploaded from the client, right? You also want to be able to listen to the uploaded file. So we need a web audio player. Next, you need to process this file with Splitter. So you need an ability to run Splitter's code, which is written in Python, by the way. And the easiest way to do so is by using the Docker image the Splitter team provides. This way, the processing would be isolated and the maintenance of this code wouldn't be complicated. So you're going to need containerization abilities to run a Docker image. Now, once the file is split into multiple sources, you can save these sources into the file system, but there is no relation between the original file and the resulting files. Hence, you'd have a hard time presenting it to the user in a way that would make sense, right? In order to make sense, for example, showing the original and the stems in a single view in the client, you need to save and maintain the relation between the original file and the results, which means you're going to need a database. Now, let's say you have all these abilities. That's not enough. You don't want bots cluttering your resources by triggering random audio files processing, right? So you need a login system to protect your system. And this will only allow logged-in users to access certain pages. Expanding this idea a little bit, you want a user to see only his own uploads and splits without being able to access other users' data. So you're going to need a user management system. And, well, limiting the pages and views one can access is great. But it wouldn't stop anyone from bypassing the view layer, accessing server-side APIs, and getting their hands on other users' data. So you're going to need a permissioning system too. Each of the discussed capabilities might require a different amount of resources. Some need more memory, some are CPU hungry, and some even must have a dedicated GPU, like the splitting itself. Due to that, you'd want to split the work between multiple microservices, when each microservice runs on a server instance that is best suited for its needs. And since the workload on these services would be different, because obviously processing audio file with GPU takes more time than returning an HTML file, you'd also want the microservices to auto-scale according to the workload, right? Last but not least, in order to identify and tackle various problems you'd certainly face during development, you'll need a good logging system, which will centralize all the logs in a single place and will allow you to trace the flow easily. Sounds about right? Great. So what does Wix have to offer here? Essentially, everything except for the actual audio processing can be done with Wix. And the audio processing itself, well, it can be done in dozens of ways on multiple platforms, but I chose AWS because, I don't know, it sounds nice. Well, to sum it up, audio processing happens on AWS, and everything else happens on Wix. AWS and Wix exchange information, thus providing a seamless user experience. Now, the first thing I did after researching Wix's capabilities and splitting the responsibilities between Wix and AWS was implementing the audio processing on AWS. Although Wix had a bunch of functionality to offer, none of it would have mattered if I couldn't get the audio processing working. And by working, I mean having the service up and running on AWS, to which I could feed an audio file and get the split stems. But before we dive in, I'd like you to meet someone. This little fella name is Dima. Dima is actually a real person, a friend of mine. You know, I run a D&D campaign for my friends, and before that, I was playing D&D as a player character. And Dima was my dungeon master. Now, he had run 3 campaigns I was part of, and he has never finished even one of them. Not a single campaign. So even though I'm mad at Dima, and I do want to help him and make him run at least one campaign from the very beginning to the very end. So Dima is going to accompany and guide us throughout the whole process, and I wish him luck. So, as I mentioned, Splitter provides a Docker image which can be run as a black box, literally, inside a Docker container. The way it works is that you just take your original track, feed it to this container, and the track is magically getting separated into separate stems by the Splitter image. So the easiest way for me to proceed was to add functionality on top of this image. Since you can't just have your file on your local storage and feed it to a service that runs on the cloud, you need some way to communicate between the two. So the updated Docker image would have to, instead of getting a file as an input, it would have to get a download URL and upload URL as an input. And then it would download the file from the download URL, feed it to the black box Splitter Docker image. It will get split by Docker, and then the result would be uploaded to the upload image. By the way, in the previous slide, you saw multiple outputs, but for the sake of simplicity, we'll focus on drums output. Why drums? Well, let the drums for once to be in the front stage. So this is pretty encapsulated and can be easily tested locally before uploading to AWS. So after messing around with Docker and making the new image work locally, I could finally upload it to AWS ECR and try it out. A few words about ECR, which stands for Elastic Container Registry. The way it works is just as we saw in the previous slides, we defined our Docker image visually. You define your Docker image in a Docker file textually. Then from this Docker file, you create an image with the help of Docker, and then you publish this image, you upload it to a container registry. The image then is available to various AWS services, and the traffic for downloading this image inside AWS is free, which is pretty important because, well, there are a bunch of different container registries out there. But if you had to pay for every time someone enters your site and wants to split a track, and you have to pay for 2 giga or 3 giga of traffic, which is this is the size of the Docker image, it will cost you a fortune. So yeah, so this is why I chose AWS ECR as a container registry. Now, once the image is uploaded to the ECR, you need someone to run it and to actually do the job. And the first thing I tried was an unmanaged environment. The environment where you need to manage the instances yourself. And I ended up paying $300 fee for an instance I forgot to shut down while it did absolutely nothing for a whole month. So I decided that unmanaged environment is not for me. And I went for a managed solution where you just specify the resource requirements and the instances are managed for you by AWS. And the obvious solution, the straightforward solution for managed environment is AWS Fargate. But that sucker didn't have a GPU support, which was crucial for my mission. And then finally, I came across AWS Batch. AWS Batch consists of a few moving parts. The first one is job definition. This is where you define your resource requirements, like how much memory you need, whether you need a GPU. This is where you define user roles and stuff like that. Then you have a job, which is a unit of work. It's like an instance of job definition. This can be a Linux executable, a shell script, or a Docker image. In our case, it's the latter. Then you have compute environment. This is where you define allowed instances, like, okay, you have a job definition that requires, let's say, 2 GB of memory and 1 GPU. But then on AWS, you have different types of instances. Each of them, the instance can be a strong one with multiple GPUs, with multiple CPUs. So in compute environment, you just state the allowed instances, you define your networking and stuff like that. And the final part is queue. This is where the submitted jobs are stored until the resources become available. So if we just try to visualize this stuff, this is how it works. You have this AWS batch, which has inside it a job definition, a job queue, which has, for example, 4 jobs inside it at the moment, compute environment with 2 instances up and running. And then a job request comes in. Job request includes job definition ID and job params. Now, with the help of job definition ID, it takes a job definition on AWS and creates from it, instantiates a new job, puts it in a queue. Next, the compute environment goes to the queue and evaluates it from the beginning. Like, do I need to scale up? Do I need to scale down? Okay, let's say it scales up, adds 2 more instances, and then a job goes to the new instance and is executed, and the rest of the jobs are moving forward in the queue. Pretty simple. So this is basically it. That's what you need for audio processing on AWS. And now let's see what happens on the Wix side. Now, what happens here is that Dima teleports to another plane of existence, which, unlike AWS, is known for its hospitable environment and great conditions. And the first thing he wants to do is to upload a track. And this one is going to be pretty easy because Wix has a component just for that, upload button component, which allows visitors to upload files to your site. You can choose allowed file types like documents, audio, video, and stuff like that. In our case, it's just the audio. And once uploaded, the files are available in the media manager under visitor uploads. So this is done. Now we need to allow the AWS part to download the track from Wix and then upload the result back to Wix. So Dima teleports back to AWS. Let's see what happens here. Now, Wix's media manager provides 2 methods, which are really useful in this case: get download URL and get upload URL. Download URL just provides you with the download URL for a file that is already in media manager. And the upload URL provides you with a URL that you can pass to a third party, and that this URL can be used to upload a file later on. So just what we need. So after we get the URLs from Wix Media Manager, this is what the updated Docker image look like. It receives download URL and upload URL, which are coming from Wix Media Manager. It downloads then the file from Wix Media Manager, processed with Splitter, and uploads the result back to Wix Media Manager. Now, so we are uploading the track on the Wix side. We are able to download the track from Wix and upload the result to Wix and process with Splitter. But how does one actually connect between the two systems? Well, once the file is uploaded, it's time to send a job request to our AWS processing queue. For that, we'll use AWS Batch SDK. So AWS SDK client batch is an NPM package, and it's a JavaScript SDK for using Batch API. Triggering job is just one of the many capabilities it has, but at the moment it's just one capability we need. But anyways, that's an NPM package. What does it have to do with Wix? The thing is, Wix allows you to install and use a variety of NPM packages on your site. It's as simple as entering the Code Packages tab and clicking on the Install Package from NPM button. You then can search for a package in NPM registry, and if it was approved, you can install it right away. If it wasn't approved yet, you can request approval and receive an answer within 48 hours. And it actually works. When I first wanted to use AWS SDK client batch package, it wasn't in the list of approved packages. And one day after I submitted a request, this package had been approved and I could use it for integration with AWS. Now, integration with AWS. You can't just start using APIs. You have to define access to your APIs. And although on this slide, it's just 3 bullets, you need to create a user group, you need to create a user called SDK, and then create an access key. Well, on AWS, figuring it out on AWS is much harder because they have a lot of services, and it's not really organized in any meaningful way. But anyways, bottom line that you have to create an access key in order to be able to access your APIs on AWS side. And once you create access key, you need to consume it on the Wix side. And since storing credentials in the code is not safe, and I highly recommend you not to do that, you should be using Wix Secrets Manager. Thus, so you generate a key on AWS, you store it in Secrets Manager, Wix Secrets Manager, and then in your velo code, you can use Wix Secrets backend to access the credentials from the code. So if we visualize the process once again, this is you. You are going to AWS and generate an API key, and now it's in your head. I mean, technically it's in a clipboard, but it's also in your head. Then you take it from your head and store that key in Wix Secrets Manager. And then you're able to access from your velo code to this secret via get secret method. Then you have the API key, and you can just initialize AWS Batch SDK, and you can use the API. So what would the triggering the job look like? Your velo backend code goes to Wix Media Manager and asks for download URL and upload URL. Then it provides both URLs as parameters to the job and triggers the job. Since you already have initialized SDK, you can trigger a job on AWS. Then AWS downloads the original from Wix Media Manager using the URL we provided in job params and uploads the result back to Wix Media Manager. Cool. So we have pretty much the whole process in place. The user uploads track to Wix, it gets processed, and then the result is uploaded back to Wix. Cool. So now Dima goes on a side quest, and he wants to listen to the original. And this is going to be pretty easy as well, because Wix has a component just for that called audio player, and the component does exactly what its title suggests. Provided a file from Media Manager, it shows the metadata and allows you to listen to the file. You can set a specific track as a source for audio player in editor, but since in our case, the track is uploaded by the user, you'd want to set the source programmatically after the file is uploaded. And with this few lines of code, once the user uploaded the file, he can listen to it on your website. By the way, did you notice the console log here on the slide? in case you didn't know, all the logs which you log with console log are redirected to side events page, to logs page on your back office, and you can just see it there. Pretty convenient. So much for logging solution. Anyways, now Dima finished his side quest and he teleports to the end of his journey, which is listening to the result. And you'd probably imagine that listening to the result is as easy as listening to the original, but that's not quite true, because the result lacks context. The problem is that the original file is uploaded by a specific user during a specific session. It is then processed by AWS, and the result is uploaded by AWS via the upload link to Media Manager. However, this time it lacks any context. You won't be able to tell which original song it's related to, and you also won't be able to set the source for the audio player in a specific user session, because it all happens on the backend. So we need to create a connection between the original track, the result, and the user. How do you do that? Well, the answer is obviously collections. If I guess anyone who watches this video knows what collections are, but in case you don't, just go to Wix documentation and read about collections. In a nutshell, it's just a database, it's abstraction on top of database. So this problem can be tackled with in multiple ways, but I chose to have two collections, one for the original track, for original tracks, and the other for the result tracks, while the resulting tracks entries in the collection of split tracks will point to the original track. So every entry inside split tracks collection will have a field called original track ID, and this is how you connect it to the original track. Dataset, which is a element that connects between a collection to UI elements, and the tracks dataset that connects to tracks collection will be filtered by owner, so that every user will see only his own content, his own uploaded content, and the upload button will add a track to the tracks collection. Later on, we can connect a repeater to tracks dataset if, for example, want to list all the files that the user has uploaded. Now, the split tracks dataset will also be filtered by owner, but it will, in addition, be filtered by original track ID. Since if we want to present to the user side by side the original track and the result, and the split tracks collection contains all the results from all the users, you'd want to filter it by original track ID that is currently presented to the user. And in addition, we'll connect to the split tracks dataset audio player, since this filtered dataset will only contain a single entry, which is filtered by owner and original track ID. The audio player can be just connected with inside the editor with UI, connected to the dataset, then the track can be played. Yeah, so given these collections and datasets, the question is, how does the result find its way to the split tracks collection? We do provide the upload URL to the AWS job. It does upload the file, but who updates the collection and how is it done? Well, the answer is events. Wix provides a way for your code to react to certain system events, backend events. In order to support it, you just need to add events.js to your backend code and put the events handlers there. That's it. Now, there is a bunch of event handlers, but we're particularly interested in on-file upload event handler. It runs when a file is uploaded using the URL returned by getUpload URL function from Media Manager, and this the invocation of this event will contain information about the uploaded file and the upload context. Now, while the upload event will contain file URL, it still won't have the context for the original track, hence no original track ID whatsoever. Luckily, getUploadURL can receive an options object in which you can pass the context. This context will be provided as a second argumenter on file upload event handler when a third party uses the upload URL for uploading file. So if we look at the upload URL flow, this is what it will look like. Your velo code calls getUploadURL, calls Wix Media Manager with getUploadURL and provides it with a context, which in our case, the context is original track ID. Now, then it triggers the job on AWS, and AWS eventually uploads the result to Wix Media Manager using the upload URL we got from Wix Media Manager. But since when we got this upload URL, we provided a context, the Media Manager knows the connection between the URL and the context. And when AWS triggers the event by uploading, using this very upload URL that we received, it will know that it has to pass the context it received at the beginning to the event handler. And this will trigger on file uploaded, and you'll have the context. Now, Dima has got exhaustion level 1. Dima still tries to listen to the result. He's already got, but he's still unable to do that because although the collection is updated, the dataset is not refreshed. Hence, the audio player connected to the dataset doesn't know that the file exists. So we could just tackle this specific use case, like updating the client elements upon a backend event, but instead we'll do something more inclusive. And the idea is to add a progress field to our tracks collection and send an update message to the client every time the progress is updated. This naturally will include the use case of processing finished. We'll just update the progress to the final value, right? And this can be done with the help of data hooks and Wix real-time package. Data hooks are added on the backend side and all reside inside the data.js file. And they allow hooking into any data operation. You just export a function meeting certain naming requirements from this file, and then your hook is just invoked. We are interested in after update. We want this hook to be triggered every time the tracks collection is updated. So we get the on-file uploaded event, we update the progress inside tracks collection, and then it triggers data hook, tracks after update. Right? Now, the progress is updated, however, the data set on the client side is still not getting refreshed because the progress is updated on the collection, which is the backend side. And Dima is desperate. Will he make it to the end this time or not? Well, reacting to collection updates is not a big deal, but it's done on the backend side. How do we communicate these to the client? If we were to develop a system from scratch, the obvious solution would be WebSockets, but we're on Wix, and they have already handled it for us. The Wix real-time module contains functionality for publishing messages on channels, and this is what it looks like. You have your backend code and you have your front-end code. Your front-end code, your page on Velo, subscribes to a certain channel using Wix real-time package. Then your backend code publishes message on this channel using Wix real-time backend package. Then some magic happens, and then whoosh, you receive a message on your page code. Pretty simple. So now, if we look at the whole flow, this is what it would look like. This is your backend code. You get an on-file uploaded event. You update the progress in tracks, which triggers data hook in tracks after update. Inside the data hook, we publish a message on a channel and then it's delivered to uploads page on a client on the front end, which refers a split tracks dataset, which in turn updates result audio player, and then the user can listen to the result. Fine touch to this, since we already have this progress field inside tracks dataset, we can connect a progress bar to it. And this is like doing it is just a component away, because Wix has a component called progress bar, and it can be connected to a certain value inside certain dataset, and we already have all this in place. So here we are. Dima has reached the end. Very cool. Now let's see some live demo here. This is the site. It's built on Wix, and I choose some song kindly provided to me by my drums teacher. The file is uploaded. Then we see the progress bar and the original track. You can listen now to the original track while it's processing. Let's see here. Now, the processing part happens on AWS, as you remember. And you remember we talked about auto-scaling? Now, before I got to this site, there were actually 0 users on the site, so we didn't want any instances to be up and running. So now when I am, as a user, I upload the file, the job has been sent to AWS. We see here the status runnable. Runnable means it can be executed, but it spins up the instance, it downloads the image, stuff like that, and will take some time. Meanwhile, we'll talk about something else. What if something goes wrong? I mean, if we're on Wix side, and we want to present an error to a user when error happens, it's as simple as wrapping your code in try and catch, and I don't know, communicating it back to the front end via Wix real time, just as we saw before. Or if you're already on front end and the error is on front end, it's even simpler. But what if something goes wrong on AWS side? What if container fails to start, or instance fails to spin up, and stuff like that? The problem is that these are 2 separate ecosystems, Wix and AWS, and unless AWS reports the error back to Wix, Wix has no way to know that something went wrong. So how do we do that? How do we show an error to a user if something goes sideways on AWS? Well, Wix has functionality also for this. It allows you to expose your backend APIs from Wix side, called HTTP functions. And in order to do so, you just need to add HTTP functions JS to your backend code. Again, export a function meeting naming requirements. And then this function can be invoked by calling an HTTP endpoint. This is it. So the idea is to monitor our job in AWS, and if there is an issue, report it back to the status update function, which is an exported HTTP function. Generally, it will allow for any status updates, such as spinning up the EC2 instance, starting a container, etc. But we'll focus solely on the failed status update. So let's zoom out again and focus on AWS and communication with Wix, how it works. For that, we're going to use AWS Event Bridge. And the way it works is that many AWS services, AWS Batch included, are sending status events to AWS Event Bridge. You, as an AWS user, can define rules to match certain types of events and be redirected, or maybe do some post-processing on the event, and then redirect the event to an API destination, which can be many things again, but we are interested in an external API endpoint. And this endpoint would be our HTTP function on Wix. Now, important thing to know that all the external API endpoints on AWS require mandatory API key, which is generated by AWS and stored in AWS Secrets Manager. And then it's sent along the event data as a header inside the request. Yeah, and now we'll see why it's there. Just a sneak peek to AWS console. This is what it looks like on AWS side. Here we have detail type, batch jobs state change. We want to listen to this detail type. The source is AWS batch, and we want the detail to be status with status failed, which means only events that include this type of information that are matching to this pattern will be redirected to our API destination. Here we go. We have API destination, split me status update. And this is our HTTP function on Wix. Now, this is basically it. We have all the setup ready, and all the failed job events will be sent to our endpoint on Wix side. So let's see what happens there. First of all, it's important to understand that once exposed, an HTTP function can be accessed by anyone. So I highly recommend you to secure your HTTP functions either with a simple API key or with the HMAC authentication velo package provided by Wix, which is a bit more complicated. But here we already have the API key provided by AWS, so we can just use it. And the way it will work is that the API destination, once there is a failure on AWS side, the event will be redirected to our API destination, and the data will be sent over to Wix, to the HTTP function, with the API key in the header. Before that, we'll go one more time to Wix Secrets Manager and store that API key inside Secrets Manager. And once we receive a request inside the HTTP function, we'll fetch the API key from Secrets Manager and match it against the API key that we received on a header. If there is a match, then indeed this request was sent by AWS, and we can handle it to update the state of the corresponding track to failed. Only how do we know which track it is? The answer is that we don't at the moment. So failure event contains the job details like job ID, job status, etc., but there is no information about the track. How do we connect between the two? Well, the answer, as always, is collections. We'll just add a field called AWS job ID, and we have this ID as soon as we send a job request to AWS. So we can just add it to the existing entry of the track we're already generating. And then when the HTTP function is invoked, we can find the track by job ID, because there is a relation between a track and its job ID. And here we are. Congrats to Dima for finishing his first campaign ever. Round of applause for Dima. And let's see how our track is doing. So let's see here. It was runnable. Now it's succeeded, which means we should see here okay, so it's going to be in splits that were uploaded already. Here we see the splits, and this is the drums part. Now, there weren't much drums in the beginning, so wait for it. The leaders work. The user can listen to it on your Wix site. Pretty amazing. Well, questions in this webinar format, I guess none. Let's sum it up. In just 40 minutes, we developed, not really, but kinda, a fully auto-scalable system. Two separate ecosystems, AWS and Wix, talking to each other in different ways. On the AWS side, we have containerized jobs, a queue to store the coming jobs, GPU instances spinning up and tearing down automatically, error processing, and an event bus that redirects the errors to our Wix site. On the Wix side, we have a fully fledged user interface, which is served to users from a CDN closest to their location, thus reducing the loading time. Permissioning and user management system, logging system, file uploads, a database with update hooks, WebSockets reacting to the file upload events, server-side APIs that can be used by a third party, an audio player, and a progress bar that connects to our database. And all this is scaled automatically by Wix. Now, it took us 40 minutes to review the solution. For a person who's familiar with Wix and AWS, it would probably take a few days to develop such a system. For a software engineer who is not familiar with AWS and Wix, it would probably take a week or two to make it work. Overall, if we go to extreme with excessive testing and lots of trial and error, let's say it would take a month. Great. How much time would it take to develop such a system from scratch? Meaning without using the know-how available out of the box on Wix platform. Even if you use off-the-shelf solutions like open source libraries, you still need to understand to a certain degree how it works. You'll have to understand the system design, to know how to set up a database and which type of database to use in every use case. You'll have to understand Kubernetes to a degree where you can manage the scalability and redundancy of your services. You'll have to connect different parts of the system together and make sure they work well together. But moreover, you'll spend days on debugging shit that doesn't work. After all, I think you'll be lucky if you finish it within 3 or 4 months. And that's just the development cost. I didn't even start talking about maintenance. Think of my $300 that I paid because I wasn't quite aware of how AWS billing works. How much time and money would it cost you to find the right model that serves your needs, also during the development time? And at the same time, doesn't cost you a fortune. What about all the migrations to new technologies or database schemes that you'll inevitably face as your project grows? What about migrating away from deprecated APIs, which happens from time to time on AWS, to more cost-efficient solutions? All this burden is taken away from you by the amazing team of Wix developers that develop and improve this platform constantly, from day to day. What else there is to say? Did I know I'm going to be a good drummer? Of course I didn't, but I gave it a try. Although I'm not budget rich, but I'm enjoying myself and I do improve at drumming. Did I know that I can build this web service with Wix? Absolutely not. But I gave it a try, and here I am at the first ever Wix DevCon, sharing my story with you guys. And now in a webinar format. So what is my point? Don't be afraid to try new things. Even if you know nothing about it, even if you're not sure it's going to work out, give it a try. Worst case, you'll fail miserably, your friends will turn away from you, your partner will abandon you, and your kids will never say your name again. Thank you, and enjoy the cover.